Good evening, students. Am I audible? Am I audible?
Yes, ma'am.
Akshaya, am I audible?
Yes, ma'am.
Yes, thank you. Have you gone through the syllabus? Today we'll have only the introduction part. The screen is visible to all.
Yes, ma'am.
So, how many of you already studied problem solving using computational thinking? Shall we start the class? How many of you gone through the syllabus, data structures and algorithms? I think all of you joined in the Google Classroom. I already uploaded the syllabus, course outcome, program outcome, students outcome, objective of the course. And today or tomorrow I will upload the unit 1 PPTs. Shall we start the class?
Yes, ma'am.
Okay, our subject is data structures and algorithms. You know very well, you might have studied few programming languages, some computer science related subjects in your schooling as well as in college. And I think many of the students are 23 batch. So we all know very well data. What is data? What are the data types we have in computer programming in different programming languages like C, C++, Java, and Python. We are using the basic data types and user-defined data types, the other structured data types, object-oriented data types. So based on data only, we are getting the data structures. Data structures means data may be primary data or secondary data, or it may be the data type may be basic data types like integer, character, float, and double. By making use of the basic data types, we are getting the user-defined data types. User-defined data types are created based on the programming or based on the project by making use of the existing basic data types which are supported by the corresponding programming language. Can you say a few user-defined data types? What you used already? Say arrays, structures. Yes. Can you list out some few user-defined data types?
Strings, integers,
Yeah. So we know very well in any programming, especially in computer-based programming languages, we have the basic data types like integer, float, character, and double. Integers may be signed integers or unsigned integers. Float means numbers with a fraction. Character means any character, the ASCII character set, American Standard Code for Information Interchange, or any character from the keyboard, ASCII keyboard. Then we have the double data type. Double is also data with a fraction or floating point numbers. Float in any most of the programming languages, 4 bytes will be allotted. Double means double the size of floating point data. It may be if it is in C and C++, it is 4 bytes. Double means 8 bytes. So the basic or built-in data types are integer, character, float, and double. By making use of the basic data types, we are creating user-defined data types or user-defined data structures. Arrays, array may be an integer array, float array, character array, or double array. Linked list means, so it will be having data along with the address. Within the linked list, we have linear linked list, non-linear linked list. We have singly linked list, doubly linked list, circularly linked list. So based on linked list only, we have stacks, queues. And if you take non-linear data linked list, trees, binary trees, B trees, B plus trees, AVL trees, graphs, directed graph, undirected graph, colored graph, weighted graph. Like that, we are getting different types of user-defined data types. So these are the concepts we are going to discuss. I think there are 53 students already joined. So our subject is called data structures and algorithms, and course code is CSC 2002. It is a core subject. All the students must study. All the computer science students must study, and it's having 4 credits. 4 credits. Out of 4 credits, 3 credits for lecture, 1 credit for tutorial and practical. And we have 5 units in our subject. So the first unit called Introduction to Algorithm and Data Structure. So we'll see what is algorithm, what are the different types of algorithms, what is the complexity of the algorithm, and what is data structure. Same way, primary data structures and user-defined data structures. So today we are going to discuss the basic and fundamental concepts. So if you take the prerequisite for our subject data structures and algorithm, the basic knowledge of computer science and introduction to problem solving and programming is must to understand the concept. What is the objective of this particular subject? Why we are studying? What are the benefits we are going to get means? So it is a core subject. The students will gain to understand the various types of fundamental data structures, standard data structures, and user-defined data structures, and to make the students to learn about algorithm analysis for runtime complexities and space requirements. So to understand the algorithms and what is the space complexity and time complexity. Time complexity means how much time the program takes if you are using a particular algorithm, and space complexity means the memory space, how much memory the it will occupy in the your primary memory and secondary memory, how many lines of code, what is the how much memory space we need to run the program or the project. And the third point is to acquire knowledge of data structures and algorithms for implementing various real world problems. To solve any real world problem, we have to apply some logic, or we need to apply some, we need some data, we need to give some input, some output, and we have to do some processing. So everything is related to data and logic. So the data is the input and output and the various data sets what we are using. And we are using some logic or flow of statements that comes under algorithm. So that those are the three main objectives why we are studying this particular subject. And what are the expected outcomes from this particular subject means. So the students will be able to gain the following knowledge after studying this particular subject. The students will be able to apply the fundamental knowledge of various data structures and algorithms to analyze, design, and formulate and implement algorithm for real-time problems. So they will understand how to solve any real-time problem by using the basic knowledge of algorithms, data structures, and they will get the systematic approach how to analyze the given problem, design the problem, and formulate the solution and get the solution through various algorithms or solutions available. The second outcome is apply current techniques in data structures and algorithm principles for modeling, developing software systems. So while creating any project, we need to use some algorithm or we need to use some core idea of computer science. So say for example, if you are doing an image processing project, so in that case, what kind of algorithm we can use and what kind of technique we can use to solve the problem, whether a linear approach or a divide and conquer approach or coloring approach, formula based approach or graph based approach. So those logic we will get from the algorithms. The third objective is choose an appropriate design paradigm that solves the given problem efficiently along the appropriate data structure. So while doing the internship project or exhibition project exhibition, or while doing the phase one project, phase two project, capstone project, whatever may be the project, we have to follow some method or paradigm. So the paradigm may be, so there are a number of methods available in solving the computer science projects, maybe linear approach, waterfall method, spiral model, win-win spiral model, agile methods, extreme programming, pair programming. So like that, there are a number of methods available or paradigms or models and methodologies are available to get the project. So most nowadays, many of the projects we can say the project it may be fourth generation techniques, object oriented methodologies, or a layered approach, or client server models, or graph based models. Like that, we have a number of you will study all those concepts in the software engineering, software project management. So any project should follow some template or it should follow some method and methodology. So that particular paradigm we can identify by analyzing or by studying this subject, what is data, what kind of data we are using, this kind of data, what kind of paradigm is useful. And the fourth expected outcome is map the real world problems to algorithmic solutions. So if you are given any real world problem to solve, you have to map the particular problem with the existing algorithmic methods. Say you are given to solve, identify the automated examination system or something. So that particular automated project, automated examination system, which kind of algorithm we can use, whether we can use AI algorithms or ML algorithms, or we can use optimization techniques, or we can use graph based techniques. So like that, So some solution methods are available. When a problem is given, uh, we have to choose a particular method which best suits the given problem. So you have the problem, you need to identify the problem, then you have to create the problem statement, then you have to go for the available solution methods. The any problem can be solved using formulas or using tabulation methods or by using algorithms or by using scientific methods. So you have to choose the best optimal solution from the existing solutions, which produces the maximum efficiency. So these kind of outcomes the students will get, this kind of knowledge and skills the students will gain after studying this particular data structures and algorithms subject. And for this particular course, we have the expected student outcomes. So student outcome means, each while studying each and every subject, you will be gaining some knowledge, skill, and empowerment. So knowledge means you will get some knowledge. Skill means your programming skill may increase, or problem solving skill may increase, or reading technical writing skills may increase based on the subject. The same way, your knowledge, whether this particular knowledge what you gained is useful for your lifelong learning or entrepreneurship skills or for research skills. So what kind of outcomes the students will get after studying this particular subject? So there are five outcomes, students' outcomes. So if you are giving some input to the student should produce some expected skills or knowledge. An ability to apply the knowledge of mathematics, science, and computing appropriate to the discipline. So the by studying the subject, the students will gain some mathematical skills, scientific and computing techniques that will be useful for them while doing the project. The second outcome is an ability to analyze a problem. So whatever may be the problem, the student will analyze the problem and identify and define the computing requirements. So he will identify what are all the parameters, what are all the variables and other data structures available in the particular problem, and they can able to define and they can able to compute, code, and get the solution. The third student outcome is design, construct, and experiments as well as analyze and interpret the data. So whatever may be the problem, they can able to design the problem, they can construct the experiment while through coding or maybe simulated model or through some models or app, or it may be website, or it may be some product development. So they will get produce some output for the given problem in terms of computer based systems. Am I audible? Is there any doubt so far? The screen is visible.
Yes, ma'am.
Yes.
Yes,
So
ma'am.
any doubt in
Yes,
the
ma'am.
yes? So the fourth student outcome is an ability to apply mathematical foundation, algorithmic principles, and computer science theory. So whatever you are studying through the various concepts and logics in this subject, in the modeling and design of computer-based systems. So whatever logic you are studying, that you can apply while solving your projects, while designing the project, design of computer-based systems. The last student outcome is an ability to apply, design, and develop principles in construction of the software systems. So they will gain the ability or the skill to design and develop principles. So they can able to design and develop the projects based on the computer based principles, whatever theoretical aspects you are studying in this particular subject, especially stacks, queues, linked list, and those concepts where we can apply, where we can make use in your real-time projects. So these are the five student outcomes expected from the subject data structures and algorithms. So anybody can say what is this CO, that is objective, course objectives, student outcomes, SO, expected outcomes, students that is specific expected outcomes, CO, PO, and SO. What is this? Why we are why those things are associated with the subject? Can anybody say? Any subject you study, you can find the syllabus will contain the prerequisite Every subject is having postcode, it's having a subject name, LTP, whether L or LT or LTP, 2 credit, 1 credit, 4 credit, and every subject is having the prerequisite, core objectives, expected outcomes, student outcomes. So what is this COPO mapping, program specific outcomes, program outcomes? What is this? What is, why it is needed? What is the logic behind this concept? COPO, PSO, course outcome, program outcome mapping, program specific outcome, program outcome. Okay, go through the thing. I think every subject, whatever you studied so far, will be having PO mapping, student outcomes, program outcomes. You check it out. Okay, our next topic, our first unit is Introduction to Algorithm and Data Structures. So only 6 hours is given for this particular unit one. So 6 hours means we have within 4 classes we have to complete this unit one. 4 classes means Friday, Saturday, Tuesday, Wednesday. Okay, so in unit one, we have the following topics. What is algorithm? Introduction to algorithm, algorithmic design, complexity of the algorithms, asymptotic notations, data structures, introduction to data structures, and classification of data structures and abstract data types. So these are the topics we are going to discuss. So if you take the first topic, what is algorithm? What is the introduction part of algorithm means? So we know very well, you might have already studied in introduction to problem solving. Algorithm is an, what is algorithm? Can anybody say what is algorithm? In problem solving, you might have studied. Anybody
Ma'am,
can define algorithm?
ma'am, am I audible?
Yes.
Ma'am, algorithm is any given step-by-step procedure to solve a particular problem.
Okay, correct. What else? So step by step procedure. What kind of step by step procedure? Step by step procedure means it is in diagrammatic form, picture form, or in English like statements or textual information.
Textual information.
Yes,
English
surely
like statement.
it is in general. In olden days, we used to follow the strict rules. We'll have the observation, then record notebook for any practical. So in observation, there should be a margin, date and time, experiment number one, title of the particular experiment. Then we'll have aim, algorithmic steps. Then we'll have the diagram, flow chart or UML diagram or entity relationship diagram or data flow diagram. Then we'll have the program in C or program in C++ or program in Java. Then we'll have the sample input output. Then we'll execute the program in the system. Then we'll show the output. So all those steps are followed and we'll have one side margin. One side we'll write the aim algorithm and another side we will draw the diagram but without line. There we'll draw the flow chart or entity relationship diagram or here data flow diagram or UML, class diagram, object diagram, all those things. So in general, algorithm means step-by-step procedure, or it is a textual form of your program, what you are going to execute. The algorithm keyword is used in programming languages. So whatever may be the programming language, whether it is C programming, C++ programming, Java programming, Python programming, or VC++ or VB++, they have the older languages like Fortran, C, COBOL. So whatever may be the programming language, we will write the algorithmic steps for the program, what we are going to write and execute. So the algorithm should be free from programming language. It has to follow steps. there should be starting of the algorithm, end of the algorithm. In general, we will use the keyword step one, algorithm, step one, start the program, step two, declare all the variables, and step three, get the input of all the variables. Step 4, perform the task. Step 5, produce, store the output, display the output, and stop the program. Like that, English like statements will be written, and the English like statement should be free from any programming language. We should not use the syntax or semantics of any C or C++ or Python or Java. So the algorithm written that can be converted to corresponding diagram. It may be flow chart or data flow diagram or entity relationship diagram or any UML diagram. And based on the algorithm and the diagram, we can write the program. So when the coding comes, that time only we will decide the programming language. So the algorithm is common for algorithm written can be used to write C program, C++ program, Python program, Java program, any program, because the algorithm is written English like statement with standard keyword, standard English like sentences, so that it can be understandable to any programmer. So the algorithm is a step-by-step procedure. It is in textual form. It is free from any programming language. The syntax and semantics of any programming language should not be used while writing the algorithm. So then what is the DSE means? Data structures along with the algorithms. So DSE stands for data structures and algorithms. It is a fundamental concept in computer science that involves the study and application of various methods for organizing and processing data. So whatever data we have, if you apply the data into the particular algorithm, so we know very well algorithm is it may be machine learning algorithm or artificial intelligence algorithm, or it may be optimization algorithms, or it may be any stack based algorithm, queue based algorithm, linked list based algorithm, any algorithm. It is an system, we can say it is a template. So if you follow the template, if you put the data into the particular template, it will produce the expected outcome. So the algorithm is used to produce the expected outcome by making use of the data and data structures. So the data structures refer to the way data is organized and stored. And while algorithms are step-by-step procedures or formulas for solving the problem. So algorithms provide us to solve any problem based on the type of problem. If you take the standard data structures, arrays is a user-defined data structure, linked list, stacks, queues, trees, and graphs, hash table. So these topics only we are going to study in remaining unit 2, 3, and 4, and 5. So these are the maximum data structures we have. The data structure can be implemented, the corresponding code may be C, C++, Python, Java, any code. And the various algorithms, what we are using in programming is searching and sorting algorithms, recursive algorithms, dynamic programming algorithms, greedy algorithms. So greedy means coloring algorithms, and divide and conquer algorithm. So we know very well divide and conquer means if the problem is very complex one, we can divide the problem into unit level. Then we will find out the solution for the smallest component. Then we will merge together all the solutions to get the final solution for the given complex problem. So these are the concepts we are going to study. Then what is DSA stands for? Data structures and algorithms. And data structures, those are specific formats for organizing and storing data in computer. So we know very well the data may be primary data or secondary data. The data may be of type integer type, character type, float type, or double type. And the data structures are user-defined data types, maybe arrays, linked list, stack, queue, trees, graphs, all those things. Examples includes arrays, linked list, tree, graph, and hash tables. So if you take the algorithms or step-by-step procedures or formulas for solving the problems in computer science, algorithms are used to perform calculations, data processing, and automated reasoning. If you take the data structures and algorithms are fundamental concepts in computer science that play a big role in solving complex problems. They are building blocks for any computer application or system, allowing for efficient data organization, storage, and retrieval. Data structures refers to the way data is organized and stored in the computer memory. So these are the basic concepts related to data structures. So algorithms are step-by-step procedures or steps of rules for solving a specific problem. They define the logic and instruction required to perform a particular task efficiently. Algorithms can be simple or complex depending on the problem at hand. So the algorithm what we are going to choose is depending upon the problem what we are going to solve. It may be normal algorithms or it may be AI based algorithms, machine learning algorithms, deep learning algorithms. We have CNN, convolution neural networks, DNN, like that we have a number of algorithms. So anyhow, these are the basic concepts. We will study the concepts in topic wise. So any doubts so far?
No, ma'am.
I think
No, ma'am.
Zoom will end in another 10 minutes because it is unlicensed one. So only 45 minutes, 40 minutes it can come. I think there are all 60 students. I will take the attendance from the Zoom recordings. Attendance is recorded. And today or tomorrow I will upload the Unit 1 PPT. So today we discussed what is algorithm, what is the basic data structure. So if you take the data structure and algorithms, so the diagram gives you a clear picture. So if you take the various data structures, what we use in various programming languages, based on the primary data type, we have linked list, matrix, two-dimensional or three-dimensional matrix or grid, queues. Queues are first in, first out, stack, last in, first out, array is collection of elements, hash tables, heap structures, graphs. It may be coloring graph or it may be directed graph, undirected graph, or weighted graph, string and string operations. Then we have the tree structures, binary trees, balanced trees, AVL trees. Like that, we have a number of tree types. And if you take the algorithms, we have pattern searching algorithms, divide and conquer algorithms, searching algorithms, sorting, bitwise algorithms, greedy coloring algorithms, recursive algorithms, backtracking algorithms, mathematical based, formal language based algorithms, and dynamic programming based algorithms. So like that, we can categorize the data structures and algorithms based on the type of data and type of logic what we are using. So the combination of data structure, and algorithms, we will call it as data structures and algorithms. So you go through the basic concepts so far what we discussed. And if you have any doubt, you ask me in the next class. Today we are in some committee to submit the report of the incident happened on 24th. So there is some meeting as well as we need to submit and report also. So today, with this, we will end the class. Tomorrow, Saturday, we'll have the class. Tomorrow, we'll have complete 1.5 hours. So any doubt today? Any doubt so far? What we discussed,
No, ma'am.
the
No, ma'am.
subject,
No, ma'am.
No, ma'am.
basic concepts, and our subject is LTP course, no? So if it is LTP, so we will come under this category. So we'll have tutorial 5 marks, group activity 5 marks, lab assessment 25 marks. So if you see the syllabus, end of the syllabus, you can find 8 programs given. So the continuous assessment, the 10 marks will be given for solving the 8 problems, and we'll give additional programs, another 50 or 60 programs that you need to solve based on the concepts. So that will come under challenging task that carries 10 marks. Your lab experiment mentioned end of your syllabus that carries 10 marks. And challenging task additional programs that carries 10 marks. And Viva questions based on the lab assessment will carry 5 marks. And attendance 5 marks. Tutorial 5, group activity 5, 10, 20, 30, 35, mid exam 30, and attendance 5. So total is 70 marks internal, and a final exam, term end exam, that carries 30 marks. So any doubt in the evaluation pattern? So this is the pattern given. Mid-exam 30 marks. These components carry 35 marks. Attendance carry 5 marks. Final exam, final semester and exam carries 30 marks. And the group activity, we will think of some tutorial, maybe assignment or quiz. And for group activity, we will have some mini project. And the continuous lab assessment, you need to solve the problems. You need to write the programming using that data structures concepts. So any doubt so far what we discussed?
No, ma'am.
No, ma'am.
So you go through the
No, ma'am.
concepts. If you have any doubt, you ask me the next class, tomorrow's class. Anyhow, up to June, July 1st, you have online classes, no?
Yes, ma'am.
Yes, ma'am.
Yes. So better we can go with the Zoom. So that we will get the recording also. We can upload in the Google Classroom. So those who are missing, they can see. So I will take the attendance based on the attendance recordings. And you go through the topics in your syllabus, but fundamental concepts. If you have any doubt, you ask me in the next class. Anything else you like to add?
No, ma'am.
No more doubt means you go through the concepts. I will upload the PPT tomorrow. Few topics are pending. Any doubt related to today's class, you ask me in the next class. Okay, thank you all.
Thank you, ma'am.
Okay, thank you all.